Hey guys, I'm very excited for another episode of Show About Science. This is your host, Nate, and today we're going to be interviewing Will about chemistry. You may have already seen our other chemistry episode. That wasn't in an actual lab. This time we're in an actual lab. It's going to be a little different from the last chemistry episode, so stay tuned. Hey guys. We're here at a chemistry lab, and this is very exciting. Oh man, danger. Are we going in the danger room?
No, not the danger room.
Great. There's another danger room. Okay, apparently all the rooms on the left are danger rooms, basically. We're walking down the hall of the tech building on the campus of Northwestern University, and we're looking for Will's chemistry lab. Oh man, this is a lot of danger rooms. Oh, danger. Danger, danger. Double danger. It was a bit nerve-wracking walking by all of those signs that said, well, danger. But we finally found it. Hello.
Hello. How are you, Nate?
I'm good. I walked in and I looked around, and I have to say, I was a bit confused. In what way is this a chemistry room?
Well, this is my office, and my labs are upstairs, which we will walk through in a few minutes. You can see where we actually do our experiments.
A little secret, though. I didn't come to just see experiments. I came to share a new discovery, but that's later in the episode. First, I had a few questions for Will to answer. So, Will, could you introduce yourself?
Sure, Nate. Thanks for coming to visit me today. My name's Will Dichtel. I'm a professor of chemistry at Northwestern, and I run a research lab where we study new materials. And so I work with a team of college students and graduate students to make new materials that have never been made before, and then we figure out what they're good for and then try to design and make them better.
So, how do you start a new thing?
Well, it's a great question. One of the types of materials that we work with is really easy to design because all of the building blocks snap into place kind of like Legos. And what we're designing is both the structure, so the blocks and exactly how they fit together, and then they fit together so that there's also empty space in the material. And so we design both of those things. And so when you can control those aspects, you can get really fascinating properties out. Like you can make materials that are good for purifying water, or you can make materials that are really good for batteries and storing electricity. We also make materials that have been really amazing at detecting explosives at very low levels.
How do they detect explosives?
Well, when you want to detect explosives, what you're trying to do is really take a very, very, very small signal and amplify it to something that we can all see. And so we design a material that is fluorescent, so it glows in the dark. And in the presence of an explosive, even a tiny, tiny amount of explosive, the material will go dark.
So, say I'm going to try to either start a new thing or help someone else with what they're doing. Is there any concerns?
In terms of starting a new project in my lab, the way that it works is that we get to be really creative. We get to think about something new. We go read all of the chemical journals and we try to find something that has not been done before. And then we go see if we can figure out a new idea to make that happen. And that is one of the most fun parts about what we do. And when we're doing our best science, we are discovering something that no person has ever made or studied or touched before. And then sometimes once we've made that first discovery, we will continue working. If there's still a lot of interesting questions to be answered, sometimes we'll study a material for 6 months or a year or sometimes longer and continue to try to think of new things to do with it or new ways to study it. And so really, my lab does both of those things.
Okay, so what have you been working on recently?
Well, we're really excited about a discovery that we've made in the last year or two, and it is a new material that is really good for water purification. And the way that it works is that we take a very fancy sugar derivative. So it's kind of like the sugar that you'd put in your lemonade or cook with, but slightly different structure. And it's really, really good at sticking to pollutants when they're dissolved in water. And so what we did with the sugar is that we built it into a big open scaffold. So we made a material out of this thing that's got lots of holes in it that allow water and pollutants to flow through and come into contact with that sugar. And as a result, it strips pollutants out of water very, very, very quickly. And so we were really, really excited when we made that first discovery. And now we continue to try to improve the performance more and more. And we try to change the structure a little bit to target one pollutant over another. And we've even started a company to try to take that first discovery that happened here in our lab here at the university and try to make that into something that you might be able to use in your everyday life.
So, how could I, when I go up there, try to make something new? How will I know that something's new?
Well, that's a great question. We actually have that question a lot also. So part of knowing that something is new is that there are all sorts of tools that we can use to read all of the chemistry journals and search through what people have done in the past. And so we can be pretty confident that something that we make has not been made before. But it's not enough just to make something new. We want to make something new that has really exciting behavior. And so when we make something in the lab, we don't always know what it's going to be good for at first. And so we have to kind of guess, and we have to make a hypothesis about when we make some new material, what tests should we even run? And so that's another time that we get to be really creative. We get to think, okay, I've got this new material, what should I do?
So when I go up there, will I be able to start something new that you will continue working on?
Well, we might be rushing into that a little bit because when we do an experiment, we do a lot of careful planning first. So we don't just walk into the lab and decide very quickly what to do. We have a plan. So we design an experiment often days in advance. We will think about the safety associated with that experiment. We will get all of our materials together, and then we will study again the procedures that we need to follow, and only then will we do an experiment. But when I take you up there, we'll be able to see a couple things. First, we're going to see a lot of experiments in progress, and you're going to see students working in the lab who are doing science every day. And then we will also see a lot of the instruments that we use to do tests on these materials once we already have made them.
So I think we're ready to go up and do some chemistry.
Sounds great.
So off we went to the lab.
All right, so come on in. So this is an organic chemistry lab.
I was so excited to finally be in the lab and to learn all about the instruments they use to conduct experiments. Up first were the rotovaps.
These are some of the coolest pieces of equipment that we own. These are called rotovaps, and this guy's name is Eddie. Eddie, this is Nate. Hi, Nate.
Hi.
And so you can kind of see Eddie's got this liquid there stirring, and so he's doing a reaction where that's heating right there. And then at the top is what's called a condenser, so there's cold water. So the liquid boils up to the top in the condenser and it falls back down and it goes over and over and over again.
There's basically this tube with two bulbs, and like there's a chemical at the bottom, and then it basically like spins around really fast, and like it basically makes the chemical go up.
That's right.
You're never gonna guess what the next instrument was.
You know what that is?
What?
You have one in your kitchen. Probably. It's a microwave.
Oh.
But it doesn't look like the microwave that you heat food up in. This is a microwave that we do chemical reactions in. So we set a reaction up in the top there, and we dial in an amount of time, just like you do in your kitchen. And sometimes these microwave reactions work really, really well. It's kind of